You are sitting in a room, perhaps at a desk or on a sofa, and you are aware of the steady, rhythmic passage of seconds. You feel the weight of your body against the chair, and you assume that your existence is a continuous journey from a fixed past into an uncertain future. This feeling of now is the most intimate fact of your life. You rely on the sequence of cause and effect to navigate the world, believing that time is a universal river that flows at a constant rate for everyone and everything. However, within the 27-kilometer ring of the Large Hadron Collider, this foundational assumption has been methodically dismantled. The high-energy collisions recorded at CERN do not merely reveal the building blocks of matter. They expose a reality where the sequence you perceive is entirely absent from the underlying laws of nature. The data suggests that the passage of time is not a fundamental property of the universe, but a persistent illusion created by the specific way your brain processes information. We are forced to confront a measurement that is internally consistent within our equations, but globally incompatible with our experience of living. The central conflict we must explore is how a universe governed by timeless laws can produce the vivid yet demonstrably false sensation of a ticking clock. The architecture of the void. You look at the world and see solid objects, but at the scale of the particles accelerated at CERN, solidity is a ghost. The Large Hadron Collider functions by stripping away the layers of the macro world to see what remains when variables are pushed to their absolute limits. What physicists found is that at the most fundamental level, there is no clock ticking in the background of the vacuum. The interactions between subatomic particles do not require a temporal before or after to function. They simply exist as geometric relationships in a multidimensional field. You perceive the chair beneath you as a solid entity, a collection of matter occupying a specific point in space and moving through a specific duration of time. You assume the atoms within that chair are like tiny, hard spheres that persist from one second to the next. However, the detectors at CERN, massive instruments like ATLAS and CMS, reveal a different reality. When protons are accelerated to 99.9999991% the speed of light and forced to collide, they do not shatter into smaller bits of solid matter. Instead, they dissolve into energy, which then crystallizes back into new particles. This process demonstrates that matter is not a permanent thing that travels through time, but a localized vibration in a field that exists everywhere at once. The vacuum is not a hollow container. It is a dense, high-energy fabric composed of various fields, such as the Higgs field and the electromagnetic field. In this environment, the concept of a linear sequence collapses. In your daily life, you observe cause and effect. A glass falls, then it breaks. But at the scale of the vacuum, there is no inherent then. The fundamental equations that govern these fields are time reversible. They do not include an arrow that points toward the future. They describe a set of relationships that are balanced and static. If you were to look at the mathematical description of a particle interaction, you would find that the variable for time, often denoted as t, functions identically to a spatial coordinate like π. This suggests that the void has an architecture that is purely geometric. Imagine a mountain range. The peaks and valleys do not happen in a sequence. They exist as a single, unmoving structure. You may choose to walk over the mountains, and in your journey, you see one peak after another, creating the illusion of a sequence. But the mountains themselves are stationary. The measurements at CERN suggest the universe is a similar structure. The interactions of particles are not events that occur in a flow of time. They are the peaks in a static, multidimensional map of energy. When we observe a particle decaying, we believe we are seeing a change over time. In reality, we are seeing a specific geometric intersection in the fabric of the fields. The architecture of the void is a configuration of information that does not need a clock to sustain itself. It is a finished, totalized object. This realization is quietly disturbing because it implies that the empty space you see between objects is actually a rigid, timeless lattice. If the foundation of reality is a static field, then your experience of now is not a universal truth. It is a localized, psychological distortion. You are moving through a landscape that is already complete. The vacuum does not wait for the future to arrive. The future is already present as a coordinate within the field, as real and as fixed as the ground beneath your feet. The solidity of your world is an illusion, and the time you believe is carrying you forward is merely the way your consciousness reads the map of a frozen, eternal void. The persistence of simultaneity. You believe that now is a universal moment happening everywhere in the cosmos at once. You imagine that at this exact instant, a star is collapsing in a distant galaxy, and a child is crying in another city. But the measurements of special relativity, confirmed with extreme precision during particle decays at CERN, prove that simultaneity is relative. There is no single now that spans the universe. Your present moment is entirely dependent on your position and your velocity. This realization stems from the fact that the speed of light, denoted as c, is a cosmic speed limit that remains constant for all observers, regardless of how fast they are moving. To keep this speed constant, nature must sacrifice the consistency of time itself. When you watch a particle zip through the Large Hadron Collider's vacuum pipe at 0.99 c, the now of that particle is no longer synchronized with your now. If that particle were carrying a clock, you would see its seconds stretching out, ticking slower than your own. This is not a mechanical error or a trick of perspective. It is a fundamental restructuring of reality to accommodate the absolute nature of light. At CERN, this is measured through the lifespan of unstable particles. A muon, for instance, has a very specific, measurable lifespan before it decays into other particles. When stationary in a lab, it vanishes in a fraction of a microsecond. However, when accelerated to near light speeds, the muon lives significantly longer from your perspective. It is able to travel distances that should be mathematically impossible given its short lifespan. From the muon's perspective, however, its life has not lengthened. Instead, the distance it travels has contracted. The data shows that there is no objective agreement on the duration of the event or the distance covered. Both are variables that shift based on movement. If there is no objective duration, there can be no objective present. Imagine two events. Event A is a particle collision at one end of the detector, and event B is a collision at the other. For an observer standing still, these events might appear to happen at the exact same time. But for an observer, or a particle, moving at high speed along the beamline, event A might happen clearly before event B. Both observers are correct. There is no higher authority or universal clock that can step in to decide which event truly happened first. The problem of the present. If you attempt to define the present mathematically, you will find it has no thickness. It is a boundary between a past that no longer exists and a future that has not yet occurred. In the high-speed environment of a particle accelerator, researchers have observed that what appears as a single moment of collision is actually a complex overlap of states that do not follow a linear progression. The now you inhabit is a psychological construct with no corresponding physical structure in the fabric of reality. In the language of geometry and calculus, a point has no dimension. If you represent the timeline of the universe as a continuous line, the present is merely a point on that line. By definition, a point has a width of 0. If the present moment has a width of 0, it possesses 0 duration. This implies a disturbing physical reality. You are essentially claiming that your entire existence, your thoughts, and your physical movements occur within a window that does not physically exist. In classical physics, this was a manageable abstraction, but in the extreme precision of the experiments at CERN, this zero-width boundary becomes a measurement paradox that cannot be ignored. When researchers at CERN observe the decay of high-energy particles, they are documenting events that occur on scales as small as 10 to the power of -22 seconds. At this level of granularity, the Heisenberg uncertainty principle dictates that we cannot know both the energy of a system and the exact timing of its changes with absolute certainty. The now of a particle collision is not a sharp, definitive line. It is a statistical smear. The interaction does not happen at a specific time. It is a probability distributed across a localized region of space-time. The more we attempt to pin down the exact present of a subatomic event, the more that event dissolves into a haze of potential states. The reason you feel a continuous, robust now is due to the specific processing speed of your nervous system. Your brain takes disparate signals, the light hitting your eyes, the sound waves reaching your ears, the tactile pressure against your skin, and binds them into a single, coherent narrative. This neural integration takes approximately 80 milliseconds to complete. This means that your experience of the present is actually a collection of data points from the immediate past, edited together by your biology, create the sensation of a flowing moment. You are always living in the wake of reality, perceiving a now that has already physically vanished. If the physical world consists only of fields and coordinates, as the data from the Large Hadron Collider suggests, then there is no physical mechanism that moves the present forward. There is no motor or force in the universe that pushes the now along the timeline. In the equations of general relativity, the present is simply a label we apply to a specific coordinate, much like a "you are here" mark on a map. The mark is not an inherent property of the map itself. It is a property of the observer looking at it. The measurements at CERN confirm that the closer we look at the fundamental fabric of existence, the less evidence we find for a distinct, moving now. We find energy, we find geometry, and we find complex relationships between fields. But we do not find a physical structure that corresponds to the fleeting moment you experience as your life. The present is a phantom produced by your brain's inability to perceive the static totality of the universe. You are anchored to a boundary that, upon measurement, proves to be entirely hollow. Symmetries of the microscopic. Most of the laws of physics are time-symmetric, meaning they work exactly the same whether time runs forward or backward. If you were to watch a video of two particles colliding and then play it in reverse, there would be no way to tell which version was the correct one based on the fundamental equations. At CERN, this symmetry is a baseline reality, suggesting that the arrow of time we experience is not written into the laws of physics themselves, but is an emergent byproduct of something else entirely. When you observe a macroscopic event, such as a glass of water spilling onto the floor, you immediately recognize a chronological order. You see a transition from a state of order to a state of disorder. This is the arrow of time as dictated by entropy. However, if you were to zoom in until the glass and the floor disappeared, leaving only the individual atoms and the forces between them, that sense of direction would vanish. The fundamental equations governing those atoms, from Newton's laws of motion to the complex wave functions of quantum mechanics, are indifferent to the direction of the variable t. If you replace t with minus t in the mathematical models used to predict particle behavior at CERN, the results remain valid. The universe, at its core, does not seem to know which way the clock is supposed to tick. In the detectors of the Large Hadron Collider, physicists track the trajectories of particles like quarks, leptons, and bosons. When an electron and a positron collide and annihilate into a photon, the physics of that interaction is identical to a photon spontaneously producing an electron-positron pair. In the mathematical framework of Feynman diagrams, a positron can even be described as an electron moving backward in time. To the machinery of the universe, there is no moral or physical preference for forward motion. The equations are perfectly balanced, a static mirror where the past and future are indistinguishable. This symmetry implies that the flow of time you feel is not a fundamental force like gravity or electromagnetism. There is no time field that pushes reality forward. If there were, we would see its influence in the microscopic world, a slight bias in the way particles interact that would reveal the true direction of the universe. Instead, what we find is a profound and unsettling neutrality. The universe's fundamental laws describe a reality that is essentially a series of static snapshots, each one mathematically linked to the others, but with no inherent instruction on which snapshot comes first. You are forced to conclude that the arrow of time is a macroscopic illusion, a blurred view of reality that only appears when you look at trillions of particles at once. It is a statistical artifact, not a physical law. Just as the concept of temperature disappears when you look at a single atom, the concept of time's passage disappears when you look at the fundamental building blocks of matter. The precision of the measurements at CERN strips away this layer of human perception, leaving behind a microscopic world that is fundamentally frozen in a state of eternal symmetry. This leads to a disturbing realization about your own existence. If the laws that govern the atoms in your brain and body are time-symmetric, then the distinction you make between a memory of the past and a plan for the future is not supported by the underlying physics of the universe. You are a collection of particles whose interactions are reversible, yet you are trapped in a one-way perception of events. The arrow is not in the world, it is in your head. The data from CERN suggests that the universe does not share your sense of urgency, nor does it acknowledge the transition from yesterday to today. It is a vast, symmetric architecture, where the sequence is a story you tell yourself, rather than a fact of the vacuum. The decay of the kaon. One of the few places where nature seems to show a preference for a specific direction of time is in the decay of certain particles, like the neutral kaon. Experiments at CERN have measured a tiny, almost imperceptible imbalance in how these particles transform, known as CP violation. However, this does not prove that time exists as a flow. Rather, it suggests that the geometry of space-time has a slight tilt that we perceive as a direction, much like an ant walking on a slanted surface assumes down is a fundamental law of the universe. To understand why this is significant, you must first understand the concept of symmetry in physics. Most particles adhere to CP symmetry. This suggests that the laws of physics should remain identical if you swap a particle for its antiparticle, charge, conjugation, and mirror its spatial coordinates. Parity. If you were to watch a video of most subatomic interactions, they would look perfectly natural played backward. But the neutral kaon is different. At the CPLEAR experiment and subsequent studies at the Large Hadron Collider, physicists observed that neutral kaons do not decay into their antimatter counterparts at the exact same rate they transform back. There is a lag, a stutter in the mirror. This discovery earned a Nobel Prize because it seemed to provide the first physical arrow for time. If CP symmetry is violated, then according to a fundamental principle called the CPT theorem, time reversal symmetry, T, must also be violated to keep the overall CPT constant. This is a mathematical requirement. If the universe breaks the symmetry of charge and space, it must also break the symmetry of time to balance the cosmic ledger. You might be tempted to see this as proof that time has a forward gear. You might feel a sense of relief, thinking that your perception of time as a moving stream is finally validated by the data. However, the data does not suggest a stream. It suggests a bias in the field. Imagine you are standing in a vast, dark hall with a floor that appears perfectly level. You roll a ball, and you notice that it consistently curves slightly to the left. You do not conclude that the hall is moving to the left. You conclude that the floor is not as level as you thought. The CP violation observed at CERN is that curve. It is an indication that the multidimensional geometry of the vacuum possesses a specific orientation. It is a structural feature of the architecture, not a movement of the building itself. When you scale this up to the macro world, this microscopic tilt becomes the foundation for the second law of thermodynamics. Because of this tiny imbalance at the subatomic level, systems are statistically more likely to move toward states of higher entropy. You perceive this statistical drift as the passage of time. You see your own aging, the cooling of a cup of coffee, and the expansion of the universe as evidence of time's flow. But the neutral kaon tells a different story. It tells you that there is no flow, only a preference in the way energy distributes itself across the static dimensions of spacetime. This realization is perhaps more unsettling than the idea of a timeless void. It implies that your entire experience of history, memory, and sequence is built upon a minor defect in the symmetry of a frozen universe. You are like a passenger on a ship that has been docked in a harbor for eternity. Yet because the deck is slanted at a 3-degree angle, you are convinced you are sailing toward a horizon. The arrow of time is not a force that carries you. It is a distortion that misleads you. The CERN measurements confirm the distortion exists, but they offer no evidence for the motion you feel so viscerally. The statistical illusion. You see a glass shatter, and you know the shards will never spontaneously reassemble. This is the second law of thermodynamics, the only law of physics that demands time move in one direction. Yet, at the level of individual particles, measured in a vacuum, this law ceases to apply. Entropy, the move from order to disorder, is a statistical trend of large groups of particles, not a fundamental property of the universe. Time, in this sense, is merely a measurement of increasing chaos, not a dimension in which we travel. The shattering glass is a macro event involving roughly 10 to the power of 24 atoms. For that glass to reform, every single atom would have to reverse its trajectory with absolute precision, overcoming the statistical impossibility of such a coordinated effort. However, if you were to isolate just 2 of those atoms and record their collision, the resulting video would look identical whether played forward or backward. At the scales probed by the Large Hadron Collider, the concept of irreversibility vanishes. There is no law in the standard model of particle physics that forbids the shards from coming back together. There is only an overwhelming probability that they will not. This distinction is critical to your understanding of reality. Entropy, defined by the formula S equals K ln W, is a measure of the number of ways a system can be arranged while looking the same on the outside. There are very few ways for atoms to be arranged as a solid, functional glass, but there are an almost infinite number of ways for them to be arranged as a pile of shards. Because there are more disordered states than ordered ones, systems naturally drift toward chaos. You perceive this drift as the flow of time. You are effectively using the increasing messiness of the universe as a makeshift stopwatch. At CERN, researchers work with systems so small and high energy that the statistical pressure of entropy is often stripped away. In a single proton-proton collision, the arrow of the second law is nowhere to be found. The interaction is a pure exchange of energy and momentum that respects CPT symmetry. This reveals that time's arrow is not a fundamental pillar of the cosmos, but a blurry property that only emerges when you zoom out. It is an emergent phenomenon, much like the wetness of water. A single water molecule is not wet. Wetness is a quality that only appears when you have a billion of them interacting. In the same way, a single particle does not experience time. Time is a quality that only appears when you have a billion particles moving toward disorder. If time is merely a measurement of chaos, then the future is not a place you are going, but simply a state of higher entropy. The past is not a place you have left, but a state of lower entropy. Your sense of existing in a moving stream is a byproduct of living in a universe that began in an unnaturally ordered state, the Big Bang. We are like inhabitants of a collapsing building who mistake the falling debris for a wind blowing in one direction. The wind is not a fundamental force. It is just the result of things falling apart. This implies that if you could somehow observe the entire universe at its most fundamental level, the clock would disappear. You would see a static web of relationships where no before or after exists. The unsettling reality is that you are a biological entity designed to perceive this decay as a journey. You are tethered to a statistical illusion, convinced of a progression that the fundamental particles of your own body do not acknowledge. The universe is not unfolding. It is simply settling into a more probable arrangement of parts, and you are caught in the transition. The block universe. The logical conclusion of our current measurements is the concept of the block universe. In this model, the past, the present, and the future all exist simultaneously as a static, four-dimensional block of space-time. Your birth, your current, reading of these words, and your eventual death are all equally real and permanently fixed at different coordinates. You do not move through time. Rather, your consciousness is a thin slice moving through a frozen landscape. This concept, known formally as eternalism, is the direct mathematical output of Einstein's field equations. If time is a fourth dimension, as relativity demands, then it must possess the same ontological status as the three dimensions of space. You do not think of the city you left behind as ceasing to exist simply because you are no longer there. You understand that the city remains at its specific spatial coordinates. In a block universe, the same logic applies to time. The past is not a vanished ghost. It is simply a location behind your current position in the temporal dimension. At CERN, this model is the only one that consistently explains the behavior of particles. When physicists calculate the trajectories of colliding protons, they do not treat the particles as objects that appear, exist, and disappear. Instead, they treat them as world lines, continuous, unbroken threads stretching through the four-dimensional manifold. A particle is not a point. It is a long, static wire. The collision is the point where these wires intersect. The detectors do not record an event that is happening. They are capturing a cross-section of a geometric structure that already exists in its entirety. If you struggle to visualize this, imagine a loaf of bread. Each individual slice represents a moment of now. To you, the observer, life feels like a sequence of slices being served one by one. But the loaf itself, the entire collection of slices from beginning to end, exists as a single, solid object on the counter. The distinction between the crust at the start and the crust at the end is merely a matter of perspective. There is no physical process that creates the next slice or destroys the previous one. The future is not a void waiting to be filled. It is already there, as structurally sound and immutable as the past. This perspective renders the concept of change obsolete. If the entire timeline is fixed, then nothing ever truly happens. Every decision you think you are making, every movement of a particle in the Large Hadron Collider, and every stellar explosion in the deep cosmos is a static feature of the block. We use the word becoming to describe our lives, but physics suggests being is the more accurate term. The universe does not evolve, it just is. The sensation of flow is merely the result of your consciousness moving along its world line, like a needle on a vinyl record. The music is already pressed into the grooves. The needle just hasn't reached the end of the disc yet. The implications of the block universe are quietly devastating to our sense of agency. If your future is as real and fixed as your past, then the possibilities you imagine are simply a lack of information. You feel you have a choice because you cannot see the coordinates ahead of you. But from a perspective outside the block, a God's eye view supported by the mathematics of CERN's high-energy physics, your path is a permanent, crystalline structure. You are not writing a story. You are a character in a book that has already been printed, bound, and placed on a shelf. The unsettling truth is that the now you cherish is just one of an infinite number of equally real moments, all frozen in the absolute, unchanging silence of the fourth dimension. The geometry of information. The data collected by CERN's detectors is essentially a record of information exchange. When we analyze the results of these collisions, we see that the universe behaves like a holographic projection, where time is not a primary ingredient. Just as a two-dimensional surface can encode a three-dimensional image, the three dimensions of space we perceive may be emerging from a deeper, timeless layer of information. In this view, time is an extra variable we use to make sense of information that is actually static. In the extreme environment of the Large Hadron Collider, particles are stripped of their macro-scale identities and reduced to sets of quantum numbers: spin, charge, and mass. When these particles collide, they are essentially performing a high-speed computation. The detectors do not see objects in the traditional sense. They record the bits of information that remain after an interaction. Physicists have begun to realize that these bits are more fundamental than the particles themselves. This has led to the development of a framework where the fabric of space-time is not a stage upon which things happen, but a code that emerges from the entanglement of information. This concept is rooted in the holographic principle, which suggests that the entire volume of a space can be described by the information encoded on its boundary. If you think of the universe as a massive computer, processing doesn't happen in time. The output is simply a geometric arrangement of data. At CERN, the complexity of a collision is measured by how much information is exchanged between fields. If the universe is fundamentally made of information, then time is merely the algorithm our brains use to sort that information into a logical sequence. It is the interface, not the hardware. Consider a digital file on a hard drive. Within the binary code, there is no time. All the data for the beginning, middle, and end of a movie exists simultaneously as a series of magnetic orientations. It is only when the file is run through a processor that the passage of time is simulated for the viewer. Our measurements suggest the cosmos functions in much the same way. The interactions we observe are the pixels of a reality that is already fully rendered. We perceive change because our consciousness is limited to processing one bit of the cosmic code at a time, creating the illusion of a transition where there is only a static distribution of data. This leads to the unsettling possibility that the universe is a matryoshka of information, where what we perceive as the flow of life is actually a secondary effect of a timeless mathematical structure. This theory, supported by the study of black hole entropy and high-energy particle states, suggests that the depth of space and the duration of time are both projections. Just as a hologram can be shattered and each piece still contains the information of the whole, every point in the vacuum contains the data of the entire system. In this model, there is no need for time to pass for an event to exist. Every event is a permanent, static node in an infinite network of information. If time is a secondary projection, then our fear of the future and our regret for the past are category errors. They are responses to a sequence that does not exist at the level of the code. The geometry of information is absolute and unchanging. By measuring the most minute exchanges of energy, CERN is effectively peering behind the holographic screen, seeing the static bits of the universe for what they truly are. We are looking at a reality that is already finished, where the variable of time is nothing more than a convenient fiction designed to help a biological observer navigate a vast, unmoving sea of data. The illusion of sequence. You remember what you did yesterday, but not what you will do tomorrow, and this asymmetry convinces you that time is moving. However, memory is simply a physical record stored in the brain, much like data on a hard drive. Physics shows that the existence of a record does not require the passage of time. It only requires a specific arrangement of matter. The sequence you feel is a result of how your neural pathways are wired to prioritize certain states over others. In the laboratory, we see that what we call a record is merely a correlation between two systems. When a particle leaves a track in a cloud chamber at CERN, we call that track a record of its past motion. However, if you examine the chamber at any given moment, the track is simply a static arrangement of ionized droplets. It exists entirely in the now. The fact that this arrangement corresponds to a previous state of a particle is an inference we make, not a property of the droplets themselves. The universe does not contain a past. It only contains present configurations that carry information about other configurations. Your brain functions as a biological cloud chamber. It contains synaptic connections that are correlated with previous states of the environment. Because these correlations exist only in one direction, from low entropy to high entropy, you experience a memory of what you call the past. But if the universe is a static block universe, then the you of yesterday is just as real as the you of today. The reason the you of today has memories of yesterday, the you of yesterday has no memories of today, is not because time has flowed from one to the other. It is because of the geometric orientation of information within the block. This creates the illusion of a sequence, a narrative thread that you believe you are pulling through the needle of the present. But in physics, there is no thread. There are only discrete states. If you were to take all the slices of your life and scatter them on a table, each slice containing a brain with a specific set of memories, each version of you would feel as though they were part of a continuous sequence. The version of you at age 5 feels a sequence leading up to that point. The version of you now feels a sequence leading here. Neither version is moving. They are both static points in the manifold, each possessing an internal record that points toward a lower entropy past. At the quantum level, this becomes even more apparent. Experiments involving delayed choice suggest that the present can determine the nature of the past. If the past were a fixed, vanished series of events, this would be impossible. But if the past is simply a set of available records in the present, then changing the past is merely a matter of changing the correlations between bits of information. The sequence is not a rigid track. It is a flexible interpretation of a static data set. This leads to the realization that your sense of becoming is a trick of perspective. You are not a traveler moving down a road. You are the road itself, and your consciousness is merely looking at one section of the pavement at a time. The flow of your life is no more real than the movement of a landscape seen from a train window. The landscape isn't moving. You are simply changing your point of observation. In a universe where all moments exist simultaneously, the sequence of your life is a story told by a brain that cannot perceive the whole book at once. You are a collection of nows that believe they are a then, trapped in a narrative of your own biological making. The quantum eraser. In quantum mechanics, there are experiments where a measurement made in the present can change the behavior of a particle in the past. This phenomenon, observed in various forms at high-energy laboratories, suggests that causality is not a one-way street. If the future can influence the past, then the linear chain of events you rely on to understand your life is an illusion. The universe is not a series of events. It is a single, interconnected web where the labels before and after are interchangeable. To understand how the past can be edited, you must look at the delayed choice quantum eraser experiment. In this setup, a photon is sent through a double slit, creating a state of superposition where it essentially travels through both paths at once. Usually, if you measure which path the photon took, the interference pattern, the evidence of its wave-like nature, vanishes. However, quantum eraser goes further. It entangles the primary photon with an idler photon. Even after the primary photon has already hit the detector and been recorded, a measurement performed on the idler photon can erase the path information. When this happens, the interference pattern reappears in the past data. This implies that the choice made by the experimenter at time t2 determines the physical state of the particle at time t1. The data collected at CERN relies heavily on this non-local behavior of quantum fields. When two protons collide, the resulting shower of particles is not a sequence of independent deaths and births. Every particle in that shower is entangled, sharing a single wave function that defies spatial and temporal separation. If you alter the state of one particle, its partner, no matter how far away or how much time has passed, reflects that change instantly. This shatters the classical notion of causality, where a cause must always precede its effect. In the quantum realm, the future is not a separate domain. It is a participant in the present. If we can reach back and erase the path of a particle after it has already completed its journey, then the history of that particle was never truly settled. It remained in a state of flux until the final measurement was made. Your own history, by extension, is not a solid foundation of past events. It is a probabilistic web that remains open until the now decides what the then must have been. In a universe where the future can influence the past, the concept of a timeline becomes a circular logic. We see the universe as a tree growing from a seed, but quantum mechanics suggests the branches are helping to create the seed itself. This is not a paradox if you accept the block universe. If the past and future exist simultaneously as a single, static object, then the future measurement and the past state are just 2 points on a geometric shape. Changing one is naturally reflected in the other because they are parts of the same whole. There is no traveling back in time. There is only the internal consistency of a timeless structure. The unsettling truth is that the unbreakable chain of causality you use to define your life, the idea that your past choices created your present, is a simplification. From the perspective of the subatomic particles being smashed at CERN, the end of the experiment is just as influential as the beginning. The universe does not care about your chronological narrative. It is a self-consistent loop of information where every moment is tethered to every other moment. You are not a product of your past. You are a coordinate in a system where before and after are nothing more than directional labels on a map that has already been drawn. Causality without continuity. We assume that for event A to cause event B, there must be a continuous flow of time between them. But at the Planck scale, the smallest possible scale of reality, space and time may be pixelated or discrete. If time is not continuous, then the flow we feel is like the movement in a film made of individual static frames. Between the frames, there is no time. There is only the void. We are living in the gaps of a reality that is fundamentally discontinuous. The intuition of smoothness is a failure of your senses. When you look at a digital screen, you see fluid motion and vibrant colors. But if you were to press a magnifying glass against the glass, the image would dissolve into a grid of static, glowing pixels. The universe operates on a similar principle of quantization. Just as light is composed of discrete packets called photons, and matter is composed of discrete atoms, the fabric of space-time itself is thought to be composed of atoms of geometry. The smallest possible unit of time is the Planck time, approximately 5.39 times 10 to the power of minus 44 seconds. Below this threshold, the very concepts of before and after lose their meaning. There is no such thing as half a Planck time. There is only a jump from one state to the next. This discretization suggests that the universe does not flow in the way a river does. Instead, it flickers like a cinematic projection. Between each Planck interval, there is a literal absence of existence. Your body, your thoughts, and the entire physical world are essentially being deleted and re-rendered trillions of times every second. We perceive continuity only because our biological hardware is too slow to detect the intervals of non-existence. At CERN, the high-energy interactions occur at such immense speeds and tiny scales that they begin to brush against this grain of reality. The smooth trajectories of particles recorded in the detectors are actually a series of discrete data points reconstructed by algorithms to look like a path. If time is a series of discrete frames, then the concept of cause and effect must be re-evaluated. In a continuous world, you can imagine a force pushing an object smoothly from point A to point B. But in a quantized world, the object simply exists at frame 1 and then exists at frame 2. There is no physical bridge between the two states. The relationship between frames is not one of physical transition, but of logical consistency. The universe is a sequence of static configurations that happen to correlate with one another. Frame B follows frame A because it is the most mathematically probable successor, not because frame A pushed it into being. This discontinuity implies that the vacuum is not a silent background, but a roiling sea of quantum foam, where space and time are constantly breaking apart. In the gaps between these pixels of reality, there is no distance, no duration, and no causality. There is only a void of pure potentiality. This suggests that the stability of your life is an illusion, maintained by the sheer scale of your existence. You are a macrostructure, built on a foundation of stuttering fragments. If the universe were to stop rendering for even a fraction of a second, there would be no time for you to notice its absence, as time itself is a product of the flickering. The realization that you live in the gaps is perhaps the most unsettling implication of modern physics. It means that you do not persist through time. You are a recurring pattern in a series of disconnected snapshots. Each frame of you is a distinct entity, sharing only a memory and a set of physical laws with the frame that came before. The continuity you feel is a biological lie, a smoothing over of a reality that is fundamentally broken, jagged, and hollow. We are not traveling through time. We are flickering in and out of a timeless void, convinced by the speed of the projection that we are whole. The metric of persistence. Why does an object persist from one moment to the next? we assume it travels through time. But physics describes this as a world line in four-dimensional space-time. An object doesn't move through time. It is a long, four-dimensional structure that exists all at once. You are not a person moving through time. You are a four-dimensional worm whose tail is at your birth and whose head is at your death. Your perception only allows you to see one cross-section of this worm at a time. This conceptual shift replaces the idea of objects with events. In the high-precision environment of CERN, a particle is not a tiny ball that sits in a detector. It is a trajectory. When physicists analyze a collision, they look at the entire path a particle took through the silicon layers. This path, or world line, is a single geometric entity in the mathematical framework of Minkowski space. Just as a piece of thread exists as a whole, even if you can only see the point where it passes through a sheet of paper, a particle exists as a complete history. The persistence you observe is simply the fact that this four-dimensional thread is continuous. Consider your own body. You think of yourself as a three-dimensional being that has lasted for several decades. But if you were to look at your existence from the perspective of four-dimensional geometry, you would see a vast, undulating shape, a temporal monolith. At the earliest coordinates, the shape is small and embryonic. At later coordinates, it grows, changes shape, and eventually frays and terminates. No part of this shape is more real than any other. The child you were and the elderly person you will become are both present in the block. They do not happen and then vanish. They occupy specific, permanent coordinates in the space-time manifold. The measurement of persistence at CERN is fundamentally a measurement of the interval between these coordinates. Using the metric equation, s squared equals delta t squared minus delta x squared minus delta y squared minus delta z squared, physicists calculate the distance between events in spacetime. This metric proves that what we call time is actually just a different kind of distance. If you rotate a rod in three-dimensional space, its length in the x dimension might shrink, while its length in the y dimension grows. Similarly, in the world line of a high-speed particle, time and space can be swapped and stretched. The only thing that remains constant is the four-dimensional interval. Persistence is not a flow. It is the rigidity of this interval. This realization creates a profound sense of isolation. If your consciousness is merely a spotlight moving along the world line, then you are never truly with anyone. When you look at a loved one, you are only seeing a single three-dimensional slice of their four-dimensional totality. Their past and their future are physically present, just centimeters away in the temporal dimension. Yet they are entirely inaccessible to your perception. You are a slice of a worm looking at a slice of another worm, both of you frozen in a block that neither of you can see in its entirety. The metric of persistence reveals that there is no movement in the universe. There is only geometry. Objects do not endure through time. They extend through it. The sense of a ticking clock is just the way your consciousness navigates the length of your own world line. You are not a traveler. You are the road. And the road does not go anywhere. It simply lies there, an unmoving scar across the fabric of the vacuum. The CERN data confirms that the world lines are real and the intervals are fixed. The rest, the feeling of moving from Monday to Tuesday, is a psychological projection onto an immutable geometric truth. Relational time. Time may not be a thing that exists on its own, but rather a relationship between objects. This theory, known as relationalism, suggests that if there were no matter and no change in the universe, there would be no time. At CERN, particles are isolated in a vacuum to such an extreme degree that the standard markers of time begin to fail. Without the interaction of complex systems, time loses its meaning, suggesting it is a macro-scale convenience rather than a micro-scale fact. You often think of time as a container, a vast, empty vessel that would remain even if you emptied the universe of all its stars, planets, and atoms. You imagine an empty space where seconds continue to tick away in the darkness. But the physics of relationalism, championed by thinkers like Leibniz and later integrated into the framework of general relativity, argues that this container is an illusion. Time is not the stage, it is the choreography. It is nothing more than the relative positions of objects as they change in relation to one another. If you were to remove every particle from the universe, you wouldn't be left with empty time. You would be left with nothing. Time would cease to exist because there would be no relationships to measure. In the vacuum tubes of the Large Hadron Collider, we approach this state of non-existence. When a single particle is isolated and accelerated, it exists in a state of nearly pure isolation. For that particle, there is no external clock. There is no day or night, no ticking of a mechanical gear, no biological rhythm. Its existence is defined solely by its interactions with the fields around it. When it does not interact, its proper time remains a local variable, unconnected to the rest of the world. This isolation reveals that time is not a global property of the vacuum, but a local consequence of interaction. Time is something that happens to matter, or rather, it is something matter does. This creates a significant problem for our understanding of reality. If time is relational, then how much time has passed depends entirely on which relationships you are measuring. At the scale of the universe, there is no master clock. Every atom is its own clock, and every interaction creates a tiny, local fragment of time. What you perceive as a smooth, universal flow is actually the statistical average of trillions of independent, chaotic interactions. It is a macro-scale blurring of reality. Much like the way thousands of individual voices in a stadium merge into a single, undifferentiated roar, the countless relational shifts of particles merge into the sensation of a steady, temporal stream. When we look at the data from CERN, we see that the most fundamental processes do not require a global time variable to be calculated. The math describes how one state changes into another, using only the internal properties of the particles. The time we add to these equations is often a human-centric placeholder, a way for us to map these changes onto our own biological experience. If you were to step outside of your human perspective, you would see that the universe is not aging. It is simply shifting its configuration. There is no progress, only rearrangement. The unsettling implication of relational time is that your own life is not a journey through a pre-existing dimension. You are not using up time. Instead, you are part of a shifting web of relationships. When those relationships cease, when the atoms of your body no longer interact in the specific way that sustains your consciousness, time does not continue without you. For you, the very dimension of time dissolves. It was never a feature of the universe to begin with. It was merely the way you and the objects around you were positioned in the void. The thermodynamic trap. Our perception of time is entirely tethered to the fact that we are heat-generating biological machines. We perceive the flow of time because our brains are constantly converting energy and creating entropy. If you were a simple, non-biological system, the arrow of time would vanish. We are trapped by our own metabolism into perceiving a temporal progression that the rest of the universe does not acknowledge. The human brain is an organ of staggering energetic cost, consuming approximately 20% of the body's total oxygen, despite making up only 2% of its mass. This energy is not used merely to keep cells alive. It is used to maintain a state of extreme disequilibrium. To think, to perceive, and to remember, your neurons must constantly pump ions across membranes, burning glucose to create an electrical gradient. This process is inherently dissipative. It generates heat and increases the total entropy of the surrounding environment. Because your consciousness is a byproduct of this thermodynamic engine, your perspective is fundamentally skewed. You are like a person standing next to a roaring fire, convinced that the entire world is made of heat and smoke, unaware that the rest of the cosmos is cold and still. At CERN, we observe systems that do not share this metabolic burden. When a superconducting magnet is cooled to 1.9 Kelvin, colder than outer space, and a single particle is guided through it, the thermodynamic noise of the macroscopic world is silenced. In these conditions, the arrow of time becomes a faint, almost non-existent signal. To a particle in a state of low-energy equilibrium, there is no before or after, because there is no meaningful change in entropy. The particle does not age. It does not record a history. It simply exists in a static state of quantum potential. Our insistence that this particle is moving through time is a projection of our own biological necessity to burn energy. If you could slow your metabolism to the point of absolute zero, your perception of time would not merely slow down. It would cease to function. The flow you experience is the subjective sensation of your brain organizing information as it transitions from order to disorder. This is known as the psychological arrow of time, and it is inextricably linked to the thermodynamic arrow. Because we can only form memories by creating an entropy-increasing record in our brains, we are physically incapable of perceiving a future where entropy is lower. We are trapped in a one-way corridor of our own, mistaking the heat of our own thoughts for the movement of the universe itself. This thermodynamic trap creates a profound disconnect between the observer and the observed. We look at the stars and see a history of birth and death, of expansion and cooling. We frame the entire history of the cosmos as a narrative of time passing. But the fundamental equations of physics, the ones used to calibrate the sensors at CERN, suggest that the universe does not experience this cooling as a sequence. The cooling is a geometric distribution of energy across the four-dimensional block. The history of the universe is a static gradient, much like the temperature gradient along a metal rod. One end is hot, the other is cold. Neither end happened first. The disturbing conclusion is that time is a biological hallucination fueled by the burning of ATP in your cells. You feel the seconds ticking away because you are dying. You are a system, slowly reaching equilibrium with your surroundings. To the fundamental building blocks of matter, which do not burn, do not think, and do not decay. The concept of a deadline or a duration is meaningless. The universe is a frozen masterpiece, and we are the only ones standing in front of it, frantically checking our watches as we slowly run out of heat. The emergent property temperature is not a fundamental property of a single molecule. It is an emergent property of many molecules moving together. Physicists increasingly believe that time is similar. A single particle doesn't experience time, but when trillions of particles interact, something that looks like time emerges from the complexity. The reason CERN cannot find a time particle or a fundamental time field is that time isn't a part of the engine. It's the smoke coming out of the exhaust. When you touch a hot surface, you are feeling the collective kinetic energy of billions of atoms vibrating against your skin. However, if you were to isolate a single atom, the concept of temperature would lose all meaning. The atom has velocity, it has mass, and it has momentum, but it is not hot. Temperature is a statistical average that only appears at a certain level of complexity. In the same way, the experiments at the Large Hadron Collider deal with the fundamental constituents of reality, the raw code of the universe. At this resolution, the variable we call time behaves less like a rigid dimension and more like a collective illusion that only stabilizes when a sufficient number of quantum interactions occur. This concept of emergence suggests that the universe is timeless at its base. Within the high-energy collisions at CERN, we see particles existing in superpositions, where the order of events is blurred. A particle might transition from state A to state B, but without an observer or a surrounding environment to anchor that change, the transition doesn't happen at a specific point in time. It is only when these particles interact with the trillions of atoms in the detector, a process known as decoherence, that a definite sequence begins to form. Time, then, is the result of quantum information leaking into the macro world. It is a secondary effect, a smoothing over of the chaotic, non-linear reality of the subatomic. If time is emergent, it implies that there was a state of the universe where time did not exist at all. In the earliest moments of the Big Bang, where the density and temperature were so high that all particles were merged into a single field, the conditions for emergence were not yet met. There was no before the Big Bang, because the complexity required to generate the sensation of a before had not yet manifested. We search for the beginning of time as if it were a starting line, but it is more likely a phase transition, much like steam condensing into water. The water is the reality we inhabit, but its fluid properties are not found in the individual molecules of the steam. This puts us in a position of profound observational bias. We are macro-scale observers trying to find time in a micro-scale world where it simply doesn't exist. We are like linguists trying to find the meaning of a novel by analyzing the chemical composition of the ink. The meaning is not in the ink, it is in the arrangement of the letters. Similarly, time is not in the particles, it is in the way they are arranged and entangled across the vacuum. The failure to find a chronon, a fundamental unit of time, is not a failure of our technology, but a confirmation that we are looking for a ghost. The unsettling implication is that time is a fragile byproduct of our specific scale. If you could shrink yourself down to the size of a Higgs boson, the ticking of the clock would fade into a static, eternal present. You would see a universe that is finished, a vast geometric mosaic where change is just a difference in perspective. We perceive time because we are too large to see the truth. We are the beneficiaries of a statistical accident, living in the smoke of a cosmic engine that is itself perfectly, terrifyingly still. The absence of now. In the general theory of relativity, there is no place for a unique, universal now. Gravity warps space and time, meaning that clocks at different altitudes or near massive objects tick at different rates. If you were to fall into a black hole, an outside observer would see you frozen in time forever at the event horizon, while you would feel yourself falling normally. This discrepancy proves that there is no objective present that the universe agrees upon. To understand the severity of this absence, you must abandon the idea that time is a steady, background hum shared by all beings. Under the laws of relativity, time is a physical dimension that can be stretched, compressed, and twisted by the presence of mass and energy. This is not a theoretical abstraction. It is a measurable fact, accounted for every day in the synchronization of GPS satellites. Because the satellites are further from the Earth's gravitational well and moving at high velocities, their onboard clocks tick faster than the clocks on your phone. If engineers did not manually correct for this temporal drift, the location data on your screen would become useless within hours. The universe is telling us that there is no correct time. Your now and the satellite's now are physically different realities. When we look at the high-energy environments simulated at CERN, this fragmentation of the present becomes absolute. Particles traveling at nearly the speed of light experience time at a fraction of the rate of the stationary detectors surrounding them. For a proton circling the ring, the now of the laboratory scientists exists in its distant future. For the scientist, the proton is a blur of current activity. In this framework, there is no master clock in the center of the cosmos. Instead, the universe is a chaotic patchwork of proper times, each valid only for a specific observer at a specific velocity in a specific gravitational field. This leads to the Andromeda paradox. Imagine two people walking past each other on a sidewalk. Because they are moving at slightly different velocities, their calculated now in a distant galaxy like Andromeda could differ by several days. For one person, the alien fleet in Andromeda has already launched its invasion. For the other, the decision to launch hasn't been made yet. Both are mathematically correct within their own frames of reference. If the present were a real physical thinness that swept through the universe like a wave, such a discrepancy would be impossible. The fact that it exists proves that the present is not an objective feature of the world, but a subjective coordinate. If there is no universal now, then the idea of a past that is gone and a future that is yet to come collapses. For the universe to have a past, it would need a shared present from which to recede. But if your past is someone else's present, and your present is another person's future, then all these states must exist simultaneously. We return again to the image of a frozen, four-dimensional landscape. Within this block, there are no moving moments. There is only a static distribution of events. A star exploding, a dinosaur dying, and you, reading this sentence, are all permanently located at different points in the manifold. The absence of now is the final blow to the human ego. We feel that we are the protagonists of a story unfolding in real time, but physics suggests we are more like characters in a film strip. All the frames exist on the reel at once. The light of the projector, your consciousness, moves across the frames, creating the illusion of a now. But the film itself does not change. It does not grow. It is simply there. The CERN data, by forcing us to reconcile the behavior of particles across different relativistic frames, confirms that the present is a ghost. You are living in a universe that has already happened, and your sense of today is merely a flicker of light on a static, eternal record. The mathematical static. When physicists look for the master equation of the universe, the one that combines gravity and quantum mechanics, the variable for time often drops out of the equation entirely. The Wheeler-DeWitt equation, for instance, describes the entire universe as a static quantum state. It does not change. It does not evolve. From the perspective of the most advanced mathematics we possess, the universe is a finished, unmoving object. In your daily life, the presence of time is an undeniable constant. You use it to calculate speed, to track the growth of your children, and to predict the rotation of the planets. In almost every equation of classical physics, time, or t, is the master parameter that allows everything else to move. But when you attempt to merge the physics of the very large, general relativity, with the physics of the very small, quantum mechanics, something strange happens. As physicists like John Wheeler and Bryce DeWitt discovered, the t simply vanishes. When you write a wave function for the entire universe, there is no external clock to measure it against. The equation that describes the totality of existence, the h psi equals 0, contains no time variable. It describes a cosmos that is perpetually, fundamentally, still. This mathematical result is known as the problem of time. If the fundamental description of the universe does not include time, then the movement we see around us must be an internal illusion. Imagine a DVD. If you look at the physical disc, you are holding the entire movie in your hand. The beginning, the climax, and the credits are all there at the same time as a series of microscopic pits in the plastic. There is no time on the disc itself. There is only geometry. It is only when the laser reads the disc and a processor interprets the data that the experience of a movie begins. The Wheeler-DeWitt equation suggests the universe is the disk, and we are merely the internal processes trying to read it. At CERN, the struggle to reconcile these two pillars of physics is a daily reality. The high-energy collisions provide the data points that theorists use to test these timeless models. If time were a fundamental, independent property, we would expect to see it anchored in the deepest mathematical structures of reality. Instead, we find that the more universal our perspective becomes, the more time dissolves into a secondary, emergent effect. The equations used to describe the quantum state of the vacuum do not evolve through a series of steps. They describe a single, all-encompassing state of being. The universe does not do anything. It simply is. This leads to a perspective called the pointless universe. If there is no time in the master equation, there is no progress, no before, and no after. The Big Bang is not an event that occurred $13.8 billion years ago. It is simply one boundary of a static mathematical object. From the perspective of the math, the universe is like a complex crystalline structure. You might be standing at one corner of the crystal, looking toward another corner and calling it the future, but the crystal itself is not growing or changing. It is a finished work, a mathematical static that has always existed and always will. The unsettling realization is that our entire experience of life, our struggles, our history, our hopes for tomorrow, is essentially a rounding error in the master equation. We are local fluctuations within a global state of stillness. We perceive a sequence of events because we are trapped within the structure, unable to see the whole. But the math doesn't lie. It describes a reality where the clock has never ticked and never will. The CERN experiments continue to push us toward this final, quiet conclusion that the flow of time is a story we tell ourselves to avoid confronting the absolute, frozen silence of the equations that govern our existence. The boundary of event horizons. At the edge of a black hole, the roles of space and time are literally swapped. What was once a direction in time becomes a direction in space. This inversion, mathematically documented and observed through the behavior of matter near high-gravity environments, suggests that time is just a specific type of spatial dimension that we happen to experience as a constraint. It is a coordinate, not a force. To understand this inversion, one must look at the Schwarzschild metric, the set of equations that describe the geometry of space-time around a non-rotating mass. As you approach the event horizon of a black hole, the curvature of space-time becomes so extreme that the light cones, the paths that light and therefore causality can take, begin to tip. At the horizon itself, the light cone tilts a full 90 degrees. In our ordinary world, you have the freedom to move forward or backward in space, but you are forced to move forward in time. Once you cross that horizon, the radial direction toward the singularity becomes your new future. Just as you cannot stop the clock from ticking toward tomorrow in your room, you cannot stop your body from moving toward the center of the black hole. Space has become time-like, and time has become space-like. This phenomenon is not merely a quirk of astrophysical monsters. It reveals the interchangeable nature of the dimensions we inhabit. At CERN, physicists explore the high energy densities that mimic the conditions of the early universe, where gravity and quantum mechanics intersect. The data suggests that the distinction between length and duration is a matter of environmental perspective. If time can be swapped for space under the right conditions of mass and energy, then time cannot be the unique, fundamental flow we perceive it to be. It is a coordinate, labeled t, that is fundamentally identical to the coordinates of x, y, and z. We only perceive it as a flow because of the specific low-gravity, low-velocity region of the block universe we currently occupy. In this context, the singularity at the heart of a black hole is not a place that exists in the future. It is a point in space that has become a temporal destination. This suggests that our own future is simply a location in the four-dimensional manifold that we are currently facing. We think of the future as something that is being created as we move, but the mathematics of event horizons proves that the future is already a physical coordinate. Just as the center of the black hole is a physical location that exists even before you fall into it, your death is a physical coordinate that exists even while you are breathing. This leads to the realization that the force of time is actually the geometry of our orientation. We are like travelers on a vast, dark plain, convinced that the direction we are walking is the only direction that exists. The event horizon is a laboratory that shows us what happens when the map is rotated. When the rotation occurs, the unstoppable flow of time is revealed to be nothing more than a trajectory through a static landscape. The reason you cannot go back to yesterday is the same reason you cannot occupy two places at once. The geometry of your current world line does not allow for that specific coordinate intersection. The boundary of the event horizon is the ultimate proof that our perception of time as a passive, universal river is an error of scale. By observing matter as it is shredded by these gravitational inversions, we see the raw machinery of the universe exposed. Time is stripped of its mystery and revealed to be a rigid, geometric constraint. We are not moving through a void. We are fixed within a structure where forward is simply a direction we cannot yet see around. The CERN experiments, by probing the limits of energy and density, bring us closer to this realization that we are trapped not by the passage of hours, but by the immutable coordinates of a timeless architecture. The resolution of the particle. When we zoom in on a particle collision at CERN, we see that the particles are not points, but excitations in a field. These fields do not vibrate in time in the way we usually imagine. They exist as patterns of probability. The time it takes for a particle to appear and disappear is not a duration it experiences. It is a measurement we impose from the outside to describe a state change that is inherently timeless. You were taught that the world is made of small, pellet-like objects that bounce off one another like billiard balls on a table. In this classical view, a particle exists at time A, travels a distance, and exists at time B. But quantum field theory, the mathematical language that drives every discovery at the Large Hadron Collision Collider, replaces these pellets with something far more abstract. What we call a particle is merely a localized peak of energy in a field that spans the entire universe. Just as a wave on the ocean is not a thing separate from the water, but a behavior of the water itself, a particle is a behavior of the field. And crucially, at the fundamental level of these fields, the variable we call duration is not a property of the wave, but a limitation of our own observational equipment. When a Higgs boson is created in a collision, it exists for approximately 10 to the power of minus 22 seconds before it decays. To a human mind, this feels like an incredibly short lifespan, a tiny sliver of time. However, to the field itself, there is no sense of living or dying. The decay is a transition between states of energy that is governed by the geometry of the field. In the equations used by CERN's theorists, this 10 to the power of minus 22 seconds is represented as a width in an energy spectrum. What you perceive as a short duration is, in reality, a specific geometric spread of energy. The particle is not moving through time during its short life. It is a static feature of the field's energy landscape. This implies that the resolution of a particle is not a temporal process, but a spatial and energetic one. If you were to watch a particle collision with quantum eyes, you would not see events happening one after another. You would see a single, complex pattern of probability. In quantum mechanics, the path of a particle is described by a wave function, which includes all possible histories and outcomes simultaneously. It is only when we, the observers, interact with the system that this cloud of probabilities seems to collapse into a single event at a specific time. We are the ones who slice the cloud into before and after. The fields themselves remain in a state of timeless superposition. Consider the uncertainty in the timing of these events. The Heisenberg uncertainty principle states that the more precisely we know the energy of a particle, the less precisely we can know its timing. At the extreme energies of CERN, this uncertainty becomes so vast that the very notion of a moment of collision becomes physically meaningless. We are measuring events that have no distinct beginning or end. We are looking at a tapestry and trying to measure how long a specific thread lasts, failing to realize that the thread is a permanent part of the weave, existing in its entirety from the moment the loom was set. The resolution of the particle reveals that at the base level of reality, the ticking of the world is silent. We impose the clock on the vacuum because we are unable to perceive the static, geometric perfection of the fields. We see a flicker and call it a lifespan. We see a collision and call it an event. But the data from the detectors tells a different story. A story of a universe that does not happen, but simply is. You are not made of particles that are traveling through time. You are a complex ripple in a set of fields that have no beginning, no end, and no reason to ever change. The infinite snapshot. Imagine the universe as a stack of photographs. Each photograph is a moment. In each photo, nothing is moving. The motion only appears when you flip through the photos quickly. Our consciousness is the act of flipping the pages. But the photos themselves, the past and the future, are all sitting on the table simultaneously. The CERN data supports the idea that the stack is real, but the flipping is an internal biological process. If you examine a single frame of a film, you see a static world. A runner is frozen mid-stride, a glass is suspended in the air, and a star is caught in the precise geometry of its explosion. Within that frame, there is no velocity, only position. Velocity, the measurement of change over time, is not a property of any single frame. It is a calculation derived from comparing one frame to the next. In the subatomic realm, the detectors at the Large Hadron Collider act as high-speed shutters, capturing these snapshots of reality at the scale of femtometers. What they record are not movements, but states. A particle is detected at point A, and then a particle is detected at point B. The path between them is a mental interpolation, a line we draw to connect two frozen dots in the stack. This perspective, often called snapshot cosmology, suggests that the universe is a discrete set of configurations. In mathematics, this is represented by the configuration space of a system, a map of every possible arrangement of every particle. When we look at the results of a collision, we are essentially looking at a specific coordinate in this configuration space. The transition from one state to another does not require a flow. It only requires the existence of another coordinate. The time it took to get there is merely the distance between the 2 points in the mathematical manifold. The CERN data confirms that the laws of physics are relations between these snapshots, not a force that pushes one into the next. The unsettling question is, who or what is flipping the pages? If the stack of photos is sitting on a table, the photos are inert. They do not have an internal motor that forces them to be viewed in a specific order. In physics, this role is often attributed to the observer. Our brain is a sequential processor. It cannot perceive the entire stack at once. It can only load one configuration at a time into the theater of consciousness. This sequential loading creates the sensation of motion, much like a flip book creates the illusion of a dancing figure. But the figure is not dancing. It is a series of still drawings. The dance is a property of your eye, not the paper. This implies that your sense of living is a local internal interpretation of a global external stasis. If you were to stop flipping, the universe would not cease to exist. Every moment of your life, the moment you were born, the moment you first felt heartbreak, the moment you die, remains a permanent, unmoving photograph in the cosmic stack. These moments do not happen and then get discarded into a bin called the past. They are the fixed, eternal components of reality. The reason you cannot see your future is not because it hasn't been taken yet, but because your consciousness hasn't flipped to that page. The photo is already there, lying face down on the table, waiting for the light of your perception to hit it. At the level of fundamental particles, the stack is incredibly dense. There are no gaps, no missing frames. The continuity you feel is the result of the sheer number of these snapshots. But the data from CERN's high-energy physics reminds us that no matter how many frames we have, we never find the movement itself. We only find more frames. We find deeper, more precise configurations of the vacuum. The infinite snapshot is the ultimate reality. A universe where nothing has ever moved, nothing has ever changed, and every moment is an eternal now that is never lost, only overlooked by a mind that can only see one page at a time. The error of memory. We trust our memories as evidence that the past happened, but memory is just a configuration of neurons in the present. There is no physical law that prevents a brain from popping into existence with a full set of memories of a past that never occurred. In a timeless universe, the past is just a set of records located at a different spatial coordinate in the block. Your sense of history is a local phenomenon, not a universal truth. To understand why memory is a shaky foundation for reality, we must look at how information is stored. In the silicon trackers of the Atlas detector at CERN, a memory of a particle's passage is simply a series of ionized pixels. When a scientist looks at that data, they see a trail and conclude that a particle was there. However, the data itself is just a static state of the computer's memory at that exact microsecond. The past motion of the particle is an inference, a story the scientist tells to explain why the pixels are glowing now. Your brain does the same. A memory is not a window into a vanished realm. It is a physical arrangement of synaptic weights and neurotransmitters existing right now. This leads us to the unsettling thought experiment known as the Boltzmann brain. In a universe governed by probability and infinite time, or infinite space, it is statistically more likely for a single brain to spontaneously fluctuate into existence, complete with memories of a childhood, a career, and a family, than it is for an entire ordered universe to evolve over billions of years. While this sounds like science fiction, it highlights a profound physical truth. The state of remembering is entirely decoupled from the actual occurrence of the events remembered. If you were a Boltzmann brain, your conviction that you ate breakfast this morning would be absolute. Yet there would be no breakfast in your history, only a specific pattern of neurons that formed by chance in the void. At CERN, the high-energy states we study remind us that the universe is essentially a system of information. When two particles collide and create a shower of new matter, the history of those original particles is effectively erased and rewritten into the new state. If time were a flow, the past would be a conserved essence. But in a block universe, the past is just a different slice of the loaf. The reason you have memories of the past slices, but not the future ones, is not because the past is gone and the future hasn't happened. It is because of the direction of entropy. Your brain is a thermodynamic engine that can only record information in the direction of increasing chaos. This creates a one-way perspective that we mistake for the movement of time. Imagine a library where the books are arranged in a specific order. If you start at book 1 and read toward book 100, you will feel a sense of progression. But the library is static. Book 1 does not disappear when you move to book 2. Your memory of book 1 is just a state you carry with you as you stand in front of book 2. In this analogy, the universe is the library, and your consciousness is the reader. Your sense of history is just the baggage of information you carry at your current coordinate. The error of memory is the belief that because we remember, time must be passing. But physics shows that memory is just a structural feature of certain coordinates in spacetime. There are regions of the block universe where you exist with memories of being 5 years old, and regions where you exist with memories of being 80. These versions of you are not the same entity moving from one state to another. They are distinct, static observers located at different points in a four-dimensional landscape. Your history is not a path you have traveled. It is a collection of records that exist simultaneously with the events they describe. You are not a creature of time, but a creature of local information, forever convinced of a journey that never actually took place. The geometry of change. Change is often confused with time. We see a leaf fall and say, time passed. But change is simply the repositioning of matter in space. If you can describe every change in the universe using only spatial coordinates and the relationships between objects, the variable of time becomes redundant. Measurements at the subatomic level show that what we call time is just our way of bookkeeping the movement of energy. To understand this, we must look at how we actually measure the world. When you look at a clock, you aren't seeing time. You are seeing the spatial displacement of a hand moving across a dial, or the oscillation of a quartz crystal. Even the most precise atomic clocks at CERN rely on the spatial transition of electrons between energy levels in a cesium atom. In every instance, we use the movement of one physical object to benchmark the movement of another. We have labeled this ratio time, but at no point do we ever measure time itself. We only ever measure the geometry of change. In the high-energy collisions within the Large Hadron Collider, the concept of a second is far too blunt a tool. Instead, physicists use the geometry of the detector to reconstruct what happened. A particle's lifetime is determined by measuring the distance between where it was created and where it decayed. If a particle travels 3 millimeters before vanishing, we use its velocity to assign it a time. But the fundamental data is spatial. The universe isn't taking time to decay the particle. The particle is simply tracing a geometric path through the fields. In the math of the Standard Model, we could replace every instance of t with a spatial interval divided by a velocity constant, and the physics would remain perfectly intact. This realization suggests that time is a linguistic and mathematical shorthand, a bookkeeping device used to simplify the complex web of spatial relationships. Imagine a game of billiards. You can describe the entire game as a series of snapshots showing the balls at different coordinates. You don't need a time dimension to explain the game. You only need to know the laws of momentum and the positions of the balls. If you have the complete geometry of the table, the flow of the game is revealed as a secondary interpretation. The universe is the ultimate billiard table, and the particles are the balls. The time we perceive is just our way of tracking how the balls shift from one corner of the table to another. If change is merely geometry, then the future is just a set of spatial coordinates we haven't reached yet, and the past is a set of coordinates we no longer occupy. This removes the need for a mystical flow or an arrow of time. Instead, we live in a universe of pure relationship. One state of the vacuum relates to another state through a geometric transformation. The reason we feel a direction is because energy tends to spread out, a spatial phenomenon we call entropy. We mistake the expansion of energy through space for the passage of time through a dimension. The geometry of change teaches us that we are not moving through time. We are rearranging within space. This perspective is deeply embedded in the way CERN processes its petabytes of data. The detectors are designed to capture the where and the how much, and from that, the when is derived as a convenient fiction. By stripping away the label of time, we are left with a universe that is a vast, static map of possibilities. Every event in your life is a permanent landmark on that map. You aren't losing your past to the passage of time. You are simply moving your focus to a different coordinate in the unchanging geometry of the cosmos. The void between collisions. In the nanoseconds between collisions at CERN, there is a state where particles exist in a superposition, occupying multiple states at once. In this quantum realm, the concept of before and after loses its grip. A particle can be in state A and state B simultaneously until a measurement is made. This implies that the linear order of events is something that only crystallizes when an observer interacts with the system, not something that exists on its own. To the human mind, life is a series of ands. This happened, and then that happened. But inside the beam pipe of the Large Hadron Collider, the universe speaks in the language of ors. Before a particle strikes a detector, it exists as a wave of probability, a mathematical blur known as the wave function. Within this blur, the particle hasn't decided on a specific path or a specific moment of arrival. It exists in a temporal haze where multiple histories are woven together. This is the void of the quantum world, a place where the rigid architecture of time hasn't yet been built. It is only when the particle interacts with the macro-scale world of the detector that this haze vanishes, forcing the universe to choose a single, linear story. This process, called decoherence, is the bridge between the timeless quantum world and our time-bound classical world. At CERN, we observe this crystallization billions of times a second. When a high-energy proton collision occurs, thousands of particles spray outward. In the instant before they hit the silicon layers of the tracker, they are not yet part of a sequence. They are a superposition of events. If you were to look at the math, you would see that the equations don't distinguish between a particle moving forward or its antiparticle moving backward. The order of operations is fluid. It is only the act of measurement, the collision with the observer, that pins these possibilities down into a before and an after. This suggests that time's arrow is not a fundamental law, but a consequence of our interaction with the universe. We are like people standing in a fog, convinced that the road only exists where we can see it. But in the quantum void, there is no road, only a field of potential directions. If we didn't look, the order of events would never solidify. The implications are staggering. It means that the sequence of your life is only real because you are constantly observing it. Without the observer, the universe remains in a state of infinite now, where all possibilities exist at once, unanchored by the constraints of a timeline. Furthermore, experiments in quantum entanglement at high energies show that two particles can remain synchronized, regardless of the distance or time between them. If you change the state of one, the other reacts instantly, faster than light could ever travel between them. This spooky action suggests that, at a deeper level, the particles are not separated by space or time at all. They are part of the same singular event. The void between collisions isn't an empty space or a gap in time. It is the fundamental reality of the cosmos, a timeless, non-local unity that we only perceive as separated events because our senses are too limited to see the whole. The void between collisions reveals the fragility of our temporal perspective. We believe in a rigid sequence because our macro-scale existence depends on it. But at the resolution of a Higgs boson or a top quark, that sequence dissolves into a sea of probability. We are living in a world that is essentially waiting to be measured into existence. The flow of time is merely the sound of the universe's wave function collapsing over and over again as it meets the gaze of an observer. Beyond that gaze, in the silent gaps of the vacuum, time simply does not exist. The observer's projection. Science has long tried to remove the observer from the experiment, but quantum mechanics makes this impossible. The way we perceive time might be the lens through which we view a timeless reality. Because our brains are evolved to survive in a world of cause and effect, we project a temporal structure onto a universe that is actually a static, multidimensional mosaic. We are the ones bringing the clock to the party. To understand this projection, we must look at the measurement problem in quantum physics. At CERN, detectors like CMS or ATLAS are not merely passive recorders of events. They are active participants that force the universe to manifest in a certain way. Before a particle hits a sensor, it exists in a state of mathematical abstraction, a wave function that encompasses all possible positions and times. It is the interaction with the observer, in this case, the massive, complex machinery of the detector, that causes this wave function to collapse into a single, definite data point. We often say the detector measured the particle at a certain time, but it is more accurate to say the detector created the moment by interrupting the particle's timeless state of potential. This suggests that our perception of a moving now is a cognitive shortcut developed through millions of years of biological evolution. For a hunter-gatherer, the ability to perceive a sequence, to know that a rustle in the grass leads to a predator's strike, was a matter of life or death. Our brains are effectively causality machines. We are hardwired to stitch discrete snapshots of reality into a continuous narrative of before and after. This is similar to how your brain fills in the blind spot in your field of vision. You don't see a hole in the world because your mind projects a seamless image. Time is the ultimate fill-in, a projected continuity that allows us to navigate a universe that is actually a frozen four-dimensional block. In the high-energy vacuum of the Large Hadron Collider, we see the cracks in this projection. When we observe quantum tunneling, particles appear to move through barriers instantaneously. To our time-bound perspective, this looks like a miracle or a violation of the speed of light. But from the perspective of a timeless field, the particle isn't moving at all. It simply occupies two spatial coordinates simultaneously. The time we measure for the tunneling is an artifact of our own measuring devices, not a property of the particle's journey. We are trying to use a stopwatch to measure a landscape. The physicist John Wheeler famously proposed the participatory universe, the idea that the universe only gains a definite history through the acts of observers. If this is true, then time is not a fundamental pillar of the cosmos, but a shared subjective experience, a consensus reality. We perceive time as a flow because every human brain is running the same biological software, processing the entropy of the environment in the same direction. We are all wearing the same temporal glasses. If we could take them off, the flow would stop. We would see that the future isn't coming toward us. It is just a direction we are currently facing within a static, eternal mosaic. This realization is the ultimate humbling of the human spirit. It means that the ticking of the world isn't an objective heartbeat of the universe, but the sound of our own gears turning. The observer's projection tells us that we are not passengers on a ship traveling through the sea of time. We are the ones painting the waves onto a canvas that was finished long before we arrived. By measuring the subatomic world, CERN is showing us the canvas without the paint. It is showing us a reality where when is just a local coordinate, and the clock is nothing more than a persistent biological hallucination. The static absolute. If time does not exist, then the universe has no beginning and no end in the way we usually conceive of them. The Big Bang is not an event that happened long ago. It is simply one edge of the four-dimensional block. Your life is not a fleeting spark in the dark. It is a permanent, unchangeable feature of the cosmic architecture. The unsettling truth revealed by our best measurements is that nothing is ever lost, because nothing is ever truly past. To grasp the magnitude of the static absolute, we must revisit the concept of the block universe. In this model, the universe is a four-dimensional solid where all of space and all of time exist simultaneously. We often imagine the Big Bang as an explosion expanding into something, but general relativity suggests it is merely the southernmost point of our cosmic geometry. Just as the North Pole is not the start of the Earth, but simply a coordinate on its surface, the Big Bang is a coordinate in space-time. It is always there, eternally occurring at its specific location in the block. It does not recede into the distance. We simply occupy coordinates further away from it. At high-energy laboratories like CERN, this permanence is a mathematical necessity. When physicists calculate the scattering amplitudes of particles, the probability of what happens when they collide, they don't treat the process as a story with a beginning, middle, and end. Instead, they use Feynman diagrams, which map out the entire interaction at once. In these diagrams, time is just an axis. A particle moving forward in time is indistinguishable from its antiparticle moving backward. The math doesn't run the collision. It describes a static exchange of energy that exists as a completed geometric pattern. The detectors are capturing slices of an event that is, in its totality, an unmoving feature of the vacuum. This shift in perspective changes the meaning of human existence. We suffer from chronocentrism, the belief that the present moment is more real than the past or the future. We mourn the loss of loved ones because we believe they have vanished into a non-existent past. But the static absolute tells us that this is a perceptual error. A person's life is a specific volume of the four-dimensional block. Their birth, their laughter, and their final breath are all permanent geometric facts. They are there, at their coordinates, as surely as a mountain is there, even when you have driven past it. The mountain doesn't cease to exist because it is in your rearview mirror. The past doesn't cease to exist because your consciousness has moved to a different coordinate. Furthermore, the conservation of information, a cornerstone of modern physics, supports this permanence. Quantum mechanics suggests that information can never be truly destroyed. Even if a book is burned, the information it contained is theoretically recoverable from the smoke and ash, provided you know the positions of every atom. In a timeless universe, this conservation is even more profound. The information that constitutes you is a fixed part of the cosmic data set. You are a set of world lines woven into the fabric of space-time, and that fabric is immutable. You cannot be erased because there is no time to wash you away. The static absolute is both terrifying and deeply comforting. It is terrifying because it implies a lack of change, a universe that is essentially a frozen sculpture of unimaginable complexity. It suggests that every mistake we've made is etched into the geometry of reality forever. But it is comforting because it means that no moment is ever truly over. Every sunset you've ever watched, every hand you've ever held, is an eternal feature of the universe. We are not moving through a life that is disappearing behind us. We are part of a massive, shimmering, and eternal structure. We are the now, only from our own limited perspective. But from the perspective of the static absolute, we are infinite.